Hello class, this is Mr. DeVoe-Peterson and I want to take a quick look at chapter 7. But before I do that, I'm going to jump in the chapter 4 just to review things with you. And this has to do with some things about radio frequency. Has to do with the length of one cycle is the wavelength. Just to kind of keep that in your mind. The frequency has to do with how many cycles per second. So the more cycles per second would be high frequency connection. The amplitude has to do with the strength of the wave, right? This has a higher amplitude than this signal B does. See the difference in height? And the phase, which is kind of an interesting concept, has to do with the difference in the degree of the angle of the two waves. In this case, it's at a 90 degree, and it can cause problems. So these are characteristics of the radio frequency, but they can also be used to the advantage to make sure we have more complete transmissions from multiple devices on the wireless network. Phase is a big part of that. So let me jump back to 7 because it talks about this. And let's see. Oh, here we go. So carrier sense multiple access, collision detection. You see that on a wired network as well as collision avoidance. Wi-Fi does not offer the feature collision detection. It would never transmit if it detected anything. So it uses collision avoidance, and there's some techniques it uses. And let me come down and find it for you. Here's some things to kind of the big picture of how wireless can try to keep all your communications secure, is that the devices can detect the radio frequency, the energy of those other devices that are on the network. And then it can look at how long, it can announce how long the frame takes to traverse the wireless network, so other devices can wait that amount of time before they try again, and they space out their communications. And if they do sense something, they'll back off and wait a certain amount of time to try retransmitting again until they see that the airwaves are free from transmission, and then they can get on. Wireless is half duplex. That means one direction at a time, like walkie-talkies. Frequency hopping, spread spectrum. Those are cordless phones. They were early Wi-Fi, but now it's not used anymore. It's obsolete for Wi-Fi. And then direct sequence spread spectrum that is used, and that uses what I was talking about: phase, amplitude, and frequency characteristics of the signal, of the radio frequency signal, to try to avoid collision. And then we get into some of the technologies and speeds. We already know that channels 1, 6, and 11 are non-overlapping for the 2.4 gigahertz frequency. 5 has more channels. And so let me go past some of this stuff. They talk about throughput. And now we're getting a little bit more advanced using orthogonal frequency division multiplexing, right? So we're altering the characteristics of the radio frequency to avoid collisions. That's all we're trying to do. So these are fancy terms used to describe the techniques for doing that. So don't let this scare you. You've probably heard this term, multiple input, multiple output technology. You see that in the 802.11ac type devices, the MIMO, and the more antennas, the better the signal, the more reliability of the signal when you have multiple devices on the same area of coverage for the wireless network. So they talk about that. Different access points. I'm going to skip some of this because I said I'd keep this brief. MIMO channels, it talks about either having a 20 megahertz or 40 megahertz channel. And it gives you a pretty good example. You've got the wider channel, then there's more communication that can go on it. Co-location. So that talks about, let's see, co-location of two or more radio frequencies on the same channel. Now, if you got a Wi-Fi deployment with multiple access points, I've been involved with some of those, and they are connected with a central managing switch to manage all the transmissions between all the different access points and all the clients. They all have their secret sauce for doing the handoff from one access point coverage to another. All right, and I've been using the Ubiquity line, but there's some others that are very good too, and they've gotten much better. Adjacent channel has to do with that they're in the same physical frequency. They're not in the 1/6 and 11 channel, for instance. All right, so this is giving an example of the interference that you see with different coexistent wireless technologies. And in an enterprise deployment, you control the devices that would be on the network, so you can manage that much better. At a hotel and hospitals, you might have to accommodate some older legacy technology, and there's more of a chance for, less compatibility and slower speed because of all those things to keep transmission from avoiding collisions and therefore slowing down everything. So if you can eliminate different like 802.11n and AC and just do AC or different enterprise deployments, you don't have to worry about the other different technologies. You're going to get much faster throughput. That and this, you can see the different speeds here. And you know what? I think I'm going to end here. I don't want to make this too complex. The terms sound complex, but all you're doing is altering the characteristics of the radio frequency. And that's how you're managing this. All right, good luck.